All right, welcome back. Today in our next video for geometry, we are looking at finding the area of quadrilaterals, and more specifically, we are looking at rectangles and parallelograms. We'll explore other quadrilaterals kind of later on and break them down more specifically. As a reminder, area is just simply the area or the amount of space inside an object. So kind of like how much space it covers. Looking here at our grid, right? Basically we have a rectangle, and so area is taking that space and breaking it into these individual tiles, and it's figuring out how many tiles fit inside of that space. And that is one reason why whenever we measure area, it's always measured in square units. So for example, if we were doing like inches, it might be inches squared or centimeters squared, right? And so that's what that little 2 means, is that label. Otherwise, we can also write out the word square. In this case, we have a 3 by 4 rectangle. So if we were talking about the area of this space, we would count out that we have 12 units, because we don't know how big they are, squared would be the area inside of that rectangle. We can then use that to look at shapes then that aren't split up into squares already, because we can start to imagine, just like when you learn multiplication, you might start with arrays and then you kind of move away and visualize that. When we're looking, for example, at this rectangle, really we could imagine that it really is a 3 by 5 array, and we could even sit there and cut it up and count those number of squares. In this case, it's a 3 by 5, so our area would equal 15 inches squared. Rectangles are probably a lot of review for you, and so what we want to look at is now how do we take this and apply it to parallelograms. So parallelograms, remember, look like rectangles kind of tipped over, but basically what it is it's a shape with opposite sides that are parallel and congruent, but it doesn't have the right angles that a rectangle has. So looking over here at our example here, we see we have this rectangle when there's actually 3 different measurements. So we have this measurement right here, which we are going to call the base. We have this measurement here, which is kind of that diagonal slant. And then we see this measurement over here, kind of with this dotted line. And this dotted line with my square here showing that 90-degree angle is the height. And essentially what happens here is we could imagine cutting this part of our parallelogram off, and you could shift it over here, and it would make a rectangle that was actually 3 by 4. Meaning that when you see this kind of length, it's actually just extra information and we don't even need it. So this is what happens, is this piece basically gets shifted over here, and we have this 3 by 4 rectangle. Hopefully you've noticed then that really we just have to multiply, and we can look at 3 times 4 and the area here being 12 centimeters squared. And that's going to bring us to our formula. When we talk about area of any sort of parallelogram, we can say, instead of saying like length times width, which applies to rectangles, we are going to use the term or the terms base times height, or BH. So that B is going to stand for the length of the base, and h is going to stand for the height of the object. And one thing you might want to make a note here is that the height has to be measured from 90 degrees. So there has to be some sort of right angle whenever we're talking about the height of an object and we're using that for area. So kind of going back to this last parallelogram, it's just another example. We can also tip it up. If we were looking at this one, even if we had some of the distances, we'd be missing some information. So why don't we go ahead, we're going to sketch in our own line, and this one we're actually going to sketch in on the inside, just so you can kind of see that sometimes that happens too. We're going to give it a little right angle. We'll say that the height of this parallelogram is 9 feet. And we'll call the base 5 feet. Using our formula then, now to find the area of our parallelogram, our area, remember, is just base times height. So we're going to take the base of our parallelogram. So basically our base is always what forms that 90-degree angle with the height. So here it's going to be 5 feet times the height of our parallelogram, which is 9, giving us an area of 45, and since our unit is feet, squared.